So first thing on the agenda, we'll go over test 7, then log flashcards, and these are definitely flash cards. So like every one of them you can do you should be able at this point to do in your head pretty quickly. There's no graded homework, but I did post problems from the Roxball book that would be good practice that I definitely would hope you would do. Oh, and or the review for the test 8, first part of the final is also on there. First part of the final will be Wednesday. Second part of the final will be Friday.
5.6 should be a last lesson.
Last one. Last lecture. Or not really lecture, last whatever we do in here. Okay, so I want y'all to try these. Again, you should be able to do them very quickly. So I'll give you about 5 or 10 seconds per card. You should be able to do them in your head. Log A plus log B is the same as log of A times B. And you should be able to go backwards and forwards with those. Log A minus log B, and the base can be anything. It doesn't matter. It could be ln, this could be ln A minus ln B, or it could be log base 7A minus log base 7B. It does not matter what the base is. It was easier for me just to do them in base 10. That would be log of A divided by B. B times log A. What do you do with a coefficient if you're trying to condense it down into a single log? You make it into an exponent. That would be log A to the power of B. Write this in expanded form. Remember that when you're expanding, you should have log plus a log plus a log plus a log, however many variables there are or numbers, you would have a single log for each one of them, and then you just pull the exponents to the front. Anything in the top stays positive, anything in the bottom becomes negative. So that would be 3 log x plus 5 log y minus log r minus log z. And in the same way, you should be able to go backwards and change a lengthy, stretched out log expression into a single log. And to do that, the first thing you do is make all the coefficients into exponents. So this would become log x to the 5th. This would become log y to the 3rd. This would become log z to the 8th. Once you've done that, just write the word log in a big blob. Anything that's positive will go on the top, and anything that's negative will go into the denominator. So this one should be log x to the 5th, z to the 8th, over y to the 3rd, p. Doesn't matter, like you could put py to the 3rd, you could put z to the 8th, y to the 5th. I just put it in that order. Just as long as they're in the right spots. Rewrite this using the change of basis formula. Log base BA. And that would just be the log of A divided by the log of B. You should be able to go from logarithmic form into exponential form. And to do that, this is read, the exponent that turns B into 19 is C. So B to the C equals 19. Same way you should be able to rewrite this in logarithmic form. In logarithmic form, the exponent becomes the base. So this would be log base 2, 4.3 equals 2.1. The graph of f of x equals any number to a power, it's an exponential function is what it is, has what intercept and what asymptote. So think about when you graph like y equals 2 to the x, where would that cross an axis and what is the asymptote? And if you think about it, it's a curve that goes upward through 0, 1 infinitely. So the intercept would be 0, 1, and the asymptote would be the x-axis, which is y equals 0. And then the logarithmic function is just the inverse of the exponential function. So if you flip the 0, 1, it's going to become 1, 0. And if you flip the asymptote, the y equals 0 will become x equals 0. And that's it. And again, those are on Blackboard. If you want to practice with them, it's a good idea. Okay, so let's go ahead and go over the test. Whoops. I want. Okay. So I'm going to go through this fairly quickly, and if you need more explanation, if you missed it and you need more explanation, feel free to ask questions as I go. So this one, I asked you to find the domain and simplify it. The domain is determined by the denominator. So this factors to be x minus 5 times x plus 1. And this factors to be 2 times x plus 1. Those x plus 1s do cancel, but you don't want to do that when we're talking about the domain. That would give you a whole, but it's still not defined. So the domain would be all x that's not equal to 5, because if you said x minus 5 equals 0, you get x equals 5. X plus 1 equals 0, you get x equals negative 1. So the domain is x can't equal to those two numbers. And then if you simplify this, the x plus 1s will cancel, and you're left with 2 over. Then this one says determine whether an inverse exists. If it does not pass the horizontal line test, this one does not. So that one does not have an inverse function. If it does, graph the inverse. So all you have to do is, this point is 3, 4. So the point on its inverse would be 4, 3. This point is negative 1, 3. So the point on its inverse would be 3, negative 1. This point is negative 3, negative 3. So a point on index would be negative 3, negative 3. So 4, 3. 3, negative 1. Negative 3, negative 3. Should look like that. Okay, here, perform the indicated operations and simplify. So I would factor first. So the numerator here is going to factor to be 5 times x squared minus 9, which will continue to factor to be 5 times x minus 3 times x plus 3 over x squared. times x minus 1 over 5 times x minus 3. Now you can cancel any numerator factor with any denominator factor. So I can cancel these x minus 3s, and I can cancel the 5. So I am left with x plus 3 times x minus 1 over x squared. Then on this one, the first thing you'd want to do is take care of the division, which would be to take the reciprocal of the term you're dividing by. And if you do that, you notice that it's exactly the same problem as number 3a. So it's just going to be x plus 3 times x minus 1 over x squared. On C, the first thing you have to do is find a common denominator. So the common denominator is going to be x minus 2 times x plus 2. So 2x already has that. But I have to do the second one needs the x plus 2. And if whatever I do to the denominator, I have to do the same thing to the numerator. So that's going to give me 2x. If I distribute that 1, negative 1, it's going to give me minus 1x minus 2 over x minus 2 times x plus 2. And that's going to give me x minus 2 over x minus 2 times x plus 2. And then the x minus 2's are a common factor, and they cancel, and when they cancel, you're left with a 1 in the numerator. Okay, so solving a rational equation, we're going to multiply through by the lowest common denominator. The lowest common denominator here is x plus 1 times x minus 1. So I'm going to take x over plus 1 and multiply that by x plus 1, x minus 1, plus negative 3 over x minus 1 times x plus 1 times x minus 1 equals to 3 times x plus 1 times x minus 1. So you have to multiply every single thing through. So these x plus 1s will cancel. And if I multiply x by x minus 1, get x squared minus x. These x minus 1s will cancel. And if I multiply what's left by the negative 3, negative 3x minus 3. And then this is going to be 3 times, if you multiply those, x plus 1 times x minus 1 is x squared minus 1. So this is going to give x squared minus 4x minus 3 equals 3x squared minus 3. Set the whole thing equal to 0. So that's going to be, if I subtract 3x squared from both sides, I get negative 2x squared minus 4x. And the 3's will cancel out, equals 0. And now to solve this, factor out a negative 2 and an x. X plus 2. And then set those factors equal to 0. And you'd wind up with 0 and negative 2. And then you want to check to make sure that those are in the domain. So here the domain would be all x values except for 1 and negative 1. So these are good. Okay, this one. The average cost per bicycle in dollars to build X bicycles is modeled by the function this A of X equals 80X plus 2400 over X. So this A of X is the average cost. And X is the number of bicycles. So how many bicycles must be built for the cost to be $100 per unit? So you're going to take this function and set it equal to 100. Then if you want, you can do a cross product. Get 80X plus 2400 equals to 100X. Then set the whole thing equal to 0. And that gives me negative 20X. Oh, not set. I could set it equal to 0, but I'm not going to. I'm just going to say negative 20X equals to negative 20. I got the X all by itself equals to negative 2400. And then divide by both sides by negative 20. And that's going to give me 120. So the answer would be 120 bicycles for the cost to be $100 per unit. It says find the horizontal asymptote and express it as an equation, not just a number. And a lot of people just put a number. You have to write the variable. If it's just a number, that doesn't tell me a lot. So on this one, if you look at this, the exponents are the degree in the numerator is the same as the degree in the denominator. So the horizontal asymptote is going to be y equals to 80x divided by x, which is just y equals to 80, and that's $80 because we're talking about where the graph is approaching the horizontal asymptote. So interpret the horizontal asymptote. And I took, as long as you had the right idea, I took many different things. But as the number of bicycles built increases, the cost of each bike it's close to $80. So this says for the rational function f of x equals 2 times x plus 1 over x minus 5 times x plus 1. Find the following. Define any asymptote by an equation, not just a number. All right, so the degree here in the numerator, if you multiply this, would be 2x plus 2. And in the denominator, x times x is x squared. So the degree in the numerator is smaller than the degree in the denominator. So when that happens, the horizontal asymptote is just y equals 0 because the degree in the numerator is smaller than the degree in the denominator. Find the vertical asymptote, cancel what you have in common, that would be a whole, but we're asked for the asymptote, set this equal to 0. So that's where the vertical asymptote is going to be at x equals 5. Okay, this one, the inverse function of 4, that means you're going to look at the f function and you're going to find out where you're going to look at the y value. So that would be on the f function, the y value is right here. And the x value would be 0. Then f plus g of -3 is the same thing as f of -3 plus g of -3. So f of -3 go over to -3, and that would be 0. And g of -3, if you go up, that would be 5. So that 0 plus 5 is 5. Then f of g of 0. So the first thing you're going to do is find g of 0. So go to the g function, and g of 0 is 2. So we're looking for f of 2. And f of 2 is 5. And this says g of f -1, 4. Well, we already found f -1, 4 is 0. So we're looking for g of 0. And the g function at 0 is just 2. Now this one, I wrote the problem, and I was hoping that y'all would just realize that these undo each other. So I just randomly picked the number 7 without thinking. So some of y'all actually did this. I was so proud that y'all got it because I didn't think about it when I was doing this. So to find the inverse, we're going to switch x and y. First, we're going to write it as y equals 1 over x plus 7. Switch the x and y. Solve for y. So I'm going to subtract 7 from both sides. So I have 1 over y equals to x minus 7. And if I flip this, that becomes a y. If I flip this first term, I have to flip the second one as well. So this becomes 1 over x minus 7. So this was intended, I should have just picked any number but 7. I just wanted you to see that I wanted you just to say these undo each other, and they do undo each other. However, 7 is not in the domain of the inverse. So really, this term is not defined. So I took either the number 7 or undefined, which is really the right answer. But that's not what I intended for that question. Draw a graph of any function that is not 1-to-1. You could have done anything that doesn't pass the horizontal line test. Does an inverse function exist? It does not. Okay. Any questions about that? If you ever do have questions or want to discuss with me, something, I'm always happy to do that. So just let me know. Okay, so now let's go back and finish what we were doing yesterday. And we stopped right here. How much money will you have in the account at the end of 8 years if you invest continuously? So I want y'all to try these two problems. And we will give you the equations, but you have to know where to use them. Remember that if we give you any number, quarterly, daily, monthly, you're going to use this formula. And if the problem says continuously, then you would use this formula. That's the only time you use that formula.
I know one thing that usually confuses my students on that first formula is that there's like 2 time variables in there, and they like can't figure out which one is which sometimes.
Oh, yeah, yeah. We'll talk about that. Okay, so see if you guys agree with me on this one. What I always do is I start out by defining my variables. So you're investing 15,000, so that's my P. An annual interest rate of 3.4%. So my interest rate is 0.034. Have to change the percent to a decimal. How much will you have in the account at the end of 10 years? T is the number of years. This is the number of years. And then the N is the number of times it's being compounded. So N is quarterly is 4. And then I just plug this into the formula and I get A equals 15,000. 1 plus 0.034 to the power of 4. That should give you $21,043.95. That, do y'all agree with me on that? Make sure you're checking me because I hardly ever make a mistake. It's like once every 10 years, but I could do it. You might catch me doing it every now and then. And I'm just totally being sarcastic. How much money will you have in the account at the end of 10 years if it's compounded continuously? So I know I'm using the PERT formula. Same variables as up here. So A is going to equal to 15,000 times E to the 0.034. And if you do that,
Hopefully they're doing like a mental check, right?
what's that?
I hope they do like a mental check. Should they be getting more or less on this one?
Right. Does it make sense?
So if we're compounding it continuously versus what, compounding it quarterly, should be more, right?
Should be more. It's not going to be a whole lot more because we're not working with that big of numbers, but it should be some more. Now that doesn't seem like a whole lot more, and it's not. But if you were talking about millions or billions, it would be a whole lot.
We're also doing a 3% interest.
Yeah, right.
If you crank that up, it
yeah.
differs too. Yeah.
What I thought was funny on one of the homeworks, I guess yours, one of the questions said, do this at 3%, and then the next question said, do it at 4%.
Yeah.
So you weren't comparing the same percentages. So it's like,
I think what they're trying to get at there is that your APR percentage like influences it more than the compounding period.
oh, perhaps.
Yeah, and it's a weird way to get at it.
I didn't get that at all.
Yeah,
it's
not super obvious. That's where they're going with that one.
I was like, what? Okay, so the half-life formula, the A naught, this is our starting amount. The X is the actual number of years. And the K is the half-life. Okay, so it says radioactive carbon-14, which is found in all living things, has a half-life of 5,700 years and can be used to date fossil fuels. Suppose someone has 5 grams of radioactive carbon. Write a function C of t for the amount of radioactive carbon G that will be present after t years. So my, I'm going to say C of t is equal to, the A naught is going to be 5,700 times 1/2. We don't know the number of years, so that's going to be X over half-life. Oh, sorry, 5 grams. So 5 grams is my starting amount. My half-life is 5,700 years. So that's going to be the equation. So my A naught is 5. My X, that's what I'm looking for. And my K is the 5,700 years. It says how much will be present after 200 years. So now I'm just going to plug in 200 for my X. You can change the 1/2 to a 0.5 if you want. And that gives me 4.9 grams of radioactive carbon. So
I mentioned it in the notes, but do they know what it means when you like date something from carbon? What is that called?
Say that again, Matt.
Oh, what is like what is it? What is the application? What do we call this when we date something from radioactive carbon?
Carbon dating?
Yeah, it's carbon dating.
Yeah.
It's what they're talking about when they talk about carbon dating.
Okay, so y'all try this one with iodine 131, which has a half-life of 8 days and an initial sample of 20 grams. And this time we're working in days instead of years. But that's okay because the question doesn't ask us in years, it just asks us in days. So hopefully that shouldn't be too hard. You recognize that the starting amount is 20, the half-life is 8 days. So the equation would be I of X equals 2 the starting amount, which is 20 times 1/2 times x over 8. And I got 5.5 grams of iodine. Hopefully y'all would tell me if you disagree with that. Okay, so this one says given f of x equals 3 to the power of x minus 2, graph and state the asymptote. So basically what I do is I just, on one like this, and you can do it differently if you want. I just look at the parent function here, which is going to be y equals 3 to the x. Do just a few points. And we won't be able to give you a number very big because otherwise when you have exponential graphs, they get big so fast that you're going to have to be able to see it on a small graph, it's going to have to be a relatively small number. So 3 to the negative second would be 1/9. 3 to the negative first would be 1/3. 3 to the 0, anything to the 0 power is 1. 3 to the first power is 3. And 3 to the second power is 9. So I'm going to go ahead and graph this. -2, 9. Tiny, tiny, -1, tiny, tiny. Remember that all exponential functions, if they haven't been transformed, go through 0, 1. Okay, so we're not through because I need to do the -2. So the original asymptote is y equals 0. So when I graph the function that I'm really supposed to, the asymptote has to come down 2 units also. And then I pick numbers that are easy to move down to, like the 0, 1. If I move it down 2 units, it becomes 0, -1. The 1, 3, if I move it down 2 units, it becomes 1, 1. This one, 2, 9, becomes 2, 7. And that's enough to graph the function. And then if you do it this way, highlight the final answer or point at it or something to indicate that that's it. And the asymptote would be y equals -2. Then I asked you to graph the inverse of f of x and state the asymptote. So I know the asymptote is going to be x equals -2. Oops. And then I go back to the function that I've highlighted. 0, -1 would become 1, 0. 1, 1 would stay 1, 1. And 2, 7 would become 7, 2. And these tiny little numbers down here, I'm not going to worry about because I know the base. I know it's going to be asymptotic to this x equals -2. So 7, 2, 1, 1. Zero, -1. Oh, this should be -1, not 1. I'm like, that doesn't make sense. Okay. So this would be -1, 0. It would look like that. This one we're going to skip for now because we haven't solved these kind of equations. So we could do it, but I'm not going to do it today. We'll probably come back and visit that another day after Matt's taught solving equations. All right, so I would like y'all to try this one. F of x equals 2 to the power of x minus 3. So again, I usually just start with the parent function to do the x and plot points for that, and then do the shift down 3. You could do the shift in the chart if you wanted to, that you could do another column and do 2 to the x minus 3 and get those points right off the bat and not have 2 on your paper. So if you prefer that way, that's fine. And the asymptote shifts as well. So it started at y equals 0 and goes down to y equals -3. Then to graph the inverse, just take some nice points off the original graph. Now, be aware that the new asymptote is going to be x equals -3. So 0, -2, -2, 0. This 1, -1 would become -1, 1. And this 2, 1 would become 1, 2. And that's enough to graph the curve. And again, we're not going to do this just yet. All right, so given that f of x equals log base 2x plus 5. Okay, so I do not like thinking backwards. I just don't. So what I always do is I go, okay, this, the inverse of that would be y equals 2 to the power of x. And that's where I start. So I graph this first. Or find points for it first. Then I'm going to switch the x and the y and shift up 5 units. Okay, so y equals 2 to the x. Would be 1, 4, 1/2, 1, 2, 4. So if I switch those, zero, 2, 1, 4, 2. I'm going to go ahead and graph that. And I know for the log without any transformations, it's always going to have a vertical asymptote at x equals 0. So 1/4 -2, -1, super tiny. 1, 0, 2, 1, 4, 2. So it's going to look like this. But then I'm not through because now I have to shift everything up 5 units. The vertical asymptote's not going to change at all. So I'm going to take all these points, I'm going to pick some nice ones and shift them up 5. 5. 2, 1, 2. So that is what it would look like. The asymptote would stay the same. Then this is it's just so repetitious now. And then just graph the inverse. So if you graph the inverse, you switch the x and the y. So here I'm going to switch. This is 1, 5. So I would graph 5, 1. This is 2, 6. So I'll go 6, 2. This one was 3, 7. So 7, 3. And I know that since the vertical asymptote here was y equals 0, x equals 0. Here it's going to be y equals 0. And that's what the inverse would look like. So we're finding functions, their inverses, and then finding the inverse of the inverse. Now this one, the difference here, we're going to run out of time, but the difference here is when you switch your x and y, you're still going to be looking for y equals 3 to the x first. Then you would find the inverse by switching the x and the y. But then you would shift those points to the left 5. So now the asymptote is going to change. So the asymptote would become x equals to -5. Let's go ahead and do, we have a little bit of time, so we'll do this last one. So I know 3 to the x. Switch those. So 1/9 -2. Now we have to shift to the left 5, including the asymptote. Pick some nice points. So 1, 0 would be kind of -4, 0. And what did we say? 1, 3, 1. Would become -4, 1. -3, 1. And 9 would become 4, 4, 2. Something. All right, so then again, when you graph f -1x, I'm just going to do a real quick version of this. I know that my asymptote, instead of x equals -5, is going to be y equals -5. Instead of going through -4, 0, it's going to go through 0, -4. Instead of going through 4-2, it's gonna go through to 4. So it's gonna look something like that. Okay, you guys, that's it for today. I will hang on. If anyone has any questions about anything, feel free to stay with me after class. But otherwise, have a wonderful weekend.
Thank you.
I'll take
Thank you.
care.
Have a nice day.
You
Take
too.
care.